Welcome to my 18th tutoring session in A-level chemistry. In this video, you will learn about periodic trends in atomic size. Please take a moment to watch my previous videos on topics isoelectronic series, shielding effect, effective nuclear charge, sizes of electrical neutral atoms and charged ions. These videos will provide a better understanding of the video content. Links to these videos are given in the description. Please do watch the videos. What is atomic radius? Atomic radius refers to the size of an atom, specifically the distance from the nucleus of an atom to the outermost electronic shell in a neutral atom. It is difficult to determine the radius of a neutral atom as the electrons are orbiting around the nucleus. That is to say, they are in a state of constant motion. It is difficult to predict or locate the exact position of the electron in their electronic shells. Now this is a difficult, different topic altogether. This is a topic of discussion in one of my forthcoming videos entitled Chemical Bonding. Please watch out for that video. Let me explain the atomic radius with respect to calcium atom. The nucleus of calcium atom contains 20 positively charged protons. The first shell contains 2 electrons. Second shell contains 8 electrons. Third shell again contains 8 electrons. And the fourth shell contains 2 electrons. Now the atomic radius of calcium atom is 175 picometers. The distance between the nucleus and the first shell is R1. R2 is the distance between the nucleus and the second shell. R3 is the distance between the nucleus and the third shell. R4 is the distance between the nucleus and the fourth shell. As the number of shells increase, the distance between the nucleus and the outermost shell increases, and as a result, the atomic radius or the size of the atom also increases. Now, valence shell is the outermost shell with valence electrons. The valence electrons are highlighted in blue, while the core electrons present in the inner shells are highlighted in red color. Now, the inner shell electrons are also called as shielding electrons as they contribute to shielding. What is shielding? The inner core electrons partially block or reduce the electrostatic force of attraction between the positively charged protons present in the nucleus of the atom and the outermost valence electron. The concept of atomic radius is crucial in understanding the properties and behaviors of atoms and elements. The unit of measurement is picometers, and 1 picometer is equal to 10 to the power of minus 12 meters. Now going down the group, the atomic size increases. I have considered the group 2 elements as representative examples to explain why the atomic size increases going down the group. Beryllium has atomic size of 110, magnesium 140, calcium 175, strontium 190, and barium 200. So as you go down the group, the atomic size increases. Why is that? Let's find out the answer by examining the electron structures of group 2 elements beryllium, magnesium and calcium. The atomic radius is measured in picometers. 1 picometer is 10 to the power of minus 12 meters. Beryllium has 4 protons in its nucleus, 2 core electrons in the first shell and 2 valence electrons in the outermost shell. I have color coded the electrons. The valence electrons are highlighted in blue while the core electrons are highlighted in red. The core electrons are closer to the nucleus and they experience a strong attractive force and therefore very difficult to remove the core electrons. While the valence electrons are far away from the nucleus, they experience a weak attractive force and therefore easy to remove the valence electrons. Atomic number of beryllium is 4 with 4 protons in its nucleus. Electronic configuration is 1s2, 2s2. Magnesium has 12 protons in the nucleus. It has 2 electrons in the first shell, 8 electrons in the second shell and 2 valence electrons in the outermost valence shell, that is the third shell. Atomic number is 12 with 12 protons. Electronic configuration is 1s2, 2s2, 2p6, 3s2. Calcium has 20 protons in its nucleus. First shell contains 2 electrons. Second shell contains 8 core electrons. Third shell again contains 8 core electrons, while the outermost valence electron contains only 2 electrons. Now as you go down the group 2, you find the number of shells increase. Beryllium has 2 shells, magnesium has 3 shells, calcium has 4 shells. As the number of shells increase, the atomic radius also increases. As the number of shells increase, the distance between the nucleus and the outermost electron shell increases. So radius of beryllium is 110 picometers, radius of magnesium is 140 picometers, and radius of calcium is 175 picometers. Now, what are the factors affecting the atomic radius? The first factor, number of electron shells and interelectronic repulsion. So as you go down the group, you can see the number of shells increase. With the increase in number of shells, the distance between the nucleus and the outermost electron shell increases and the atomic radius also increase. So going down the group, number of shells increase and the atomic radius increases. So as a result of increase in the number of shells, the number of electrons also increase. As the number of electrons increase, it leads to electron crowding and finally there is interelectronic repulsion. Now like charges repel and negatively charged electrons is no exception. They too repel each other, and due to interelectronic repulsion, the charge spreads and occupies more space. The electron cloud expands and the atomic size increases. So there is electron-electron repulsion not only between electrons within the shell but also between the shells. Second factor affecting the atomic radius, effective nuclear charge. What is effective nuclear charge? Effective nuclear charge is the electrostatic force of attraction between the positively charged protons and the outermost valence electrons. It is also defined as the net positive charge experienced by the outermost valence electron in a multi-electron atom. Now, why is the effective nuclear charge of fluorine atom is greater than lithium? Let's find out the answer by comparing the electron structures of lithium and fluorine. So when you compare the electron structures of lithium and fluorine, you will find that lithium has 3 protons in the nucleus while fluorine has 9 protons in the nucleus. Lithium has 2 shells, fluorine has 2 shells. Lithium has only 3 electrons while fluorine has total of 9 electrons. Now the fluorine nucleus has total of 9 protons in its nucleus while lithium has 3 protons. So the magnitude of positive charge in case of fluorine atom is 3 times more than the lithium atom. As a result of this, the valence electrons in case of fluorine atom experience a strong attractive force towards the nucleus. And therefore, the effective nuclear charge is greater in case of fluorine as compared to lithium. As a result of the strong electrostatic force of attraction between the 9 protons in the nucleus of fluorine and the outermost valence electrons, the electrons are pulled closer to the nucleus, and as a result, the size of the fluorine atom shrinks or decreases. Let me further simplify this explanation. Lithium has 3 protons in the nucleus. It experiences a very weak attractive force. That is the valence electron. So what about fluorine atom? Fluorine atom has 9 protons in the nucleus, and the valence electron in case of fluorine atom experiences a strong attractive force, and it pulls the valence electron very close to the nucleus, because the magnitude of positive charge in fluorine atom is more than, fluorine is more than lithium. So fluorine pulls the electrons closer to the nucleus and size of the fluorine atom decreases. Next factor is electron shielding. Let me explain the concept of electron shielding with respect to calcium atom, as calcium atom contains more number of shells and inner core electrons. Now electron shielding also affects the atomic radius. As the number of shells increase, the number of electrons increases. With the increase in number of electrons in their respective shells, electron-electron repulsion also increases, and with increase in the electron-electron repulsion, the size of the atom increases as the electron cloud expands. Now what is electron shielding? Now shielding is a phenomenon where the inner core electrons partially block or reduce the electrostatic force of attraction between the positively charged protons present in the nucleus and the outermost negatively charged electrons. Now going down the group, you find that the number of shells increase. So with the increase in the number of shells, shielding also increases. Now each shell acts as a shield. Now in case of beryllium, it has only one shell with 2 core electrons shielding the nucleus from the outermost valence electron. In case of magnesium, it has 2 shells with a total of 10 core electrons shielding the nucleus from the outermost valence electrons. In case of calcium, it has 3 shells with a total of 18 core electrons shielding the nucleus from the outermost valence electrons. So as you go down the group, the number of shells increase, and with the increase in number of shells, shielding also increases. And as a result of this, the distance between the nucleus and the outermost shell also increases going down the group, and this decreases the electrostatic force of attraction between the positively charged protons and the outermost valence electrons. And electron shielding in calcium is greater than magnesium, because in case of calcium, there are only 3 shells with core electrons, while in case of magnesium, it has only 2 shells with core electrons. So number of shells in case of calcium is 3, while in case of magnesium it is only 2. And therefore, shielding is more in case of calcium as compared to magnesium. And because of the high shielding in calcium, the outermost valence electrons are loosely held, because they experience a weak attractive force towards the positively charged protons. Well, in case of magnesium, the outermost valence electrons, they are very close to the nucleus. They experience a very strong attractive force, and it's very difficult to remove the valence electrons. So in case of calcium, the valence electrons are loosely held and can be easily removed during the reaction. But in case of magnesium, the outermost valence electrons are tightly held because of strong electrostatic force of attraction, and harsh conditions are required in the reaction to remove the valence electrons so that they can participate in the reaction. Now, what is the use of understanding the atomic size concept? Now, understanding atomic radii or size helps in predicting the chemical reactivity of the element. Now, what is chemical reactivity? Now, chemical reactivity is a measure of the element's ability to accept or lose electrons in a reaction in order to attain the stable electronic configuration of the noble gas nearest to it in the periodic table. So chemical reactivity is a measure of element's ability to either gain electrons or lose electrons. So why do they gain or lose electrons? In order to attain the stable electronic configuration of the noble gas that is nearest to it in the periodic table. Now here the question is, why calcium is more reactive than magnesium? To answer this question, we need to examine the electron structures of calcium with that of magnesium. As I have already explained, shielding is more in case of calcium as compared to magnesium. So more the shielding, lesser will be the electrostatic force of attraction of the valence electrons towards the nuclear protons, and therefore they'll be loosely held and they can be easily removed or they can easily participate in a reaction. While in case of magnesium, the valence electrons are very close to the nucleus and they experience a very strong attractive force and they are tightly held and they can be removed or they can participate in a reaction only under harsh conditions. So in case of calcium, valence electrons are loosely held and can be easily lost during a reaction. Well, in case of magnesium, the valence electrons are tightly held and difficult to remove them. And harsh conditions are required to make the valence electrons of magnesium to participate in a reaction. Remember, it is the valence electrons that participate in the chemical reaction. So reactivity of an element depends on the valence electrons. How easily it is available to participate in a reaction. The more easily it is available, the more reactive the element is, and therefore calcium is more reactive than magnesium. So understanding atomic radii also helps in predicting the bond lengths and type of bond an atom will form, the behavior and properties of elements in various chemical reactions, and it's an important concept in chemistry and material science. Now coming to the periodic trends in atomic size. In the periodic table, to understand the trends in atomic size, we start with lithium and go across a period from left to right, the periodic table, and later we'll go down the group from lithium and study the periodic trends. So as we move from left to right in the periodic table across a period, you'll find that the atomic size or the atomic radius decreases. Why is that? So we'll start with lithium. Lithium has two shells, followed by beryllium, again with two shells. This is followed by the metalloid boron, two shells. This is followed by carbon with two shells, followed by nitrogen, two shells, oxygen, two, and fluorine also contains two shells. Now what about the number of protons? Lithium contains 3 protons in its nucleus. Beryllium contains 4 protons. Boron 5 protons. Carbon 6 protons. Nitrogen 7 protons. Oxygen 8 protons. And fluorine 9 protons. As we move from left to right across the period, the periodic table, we find the number of protons, they increase while the number of shells remain constant. So you find the number of shells in these elements to be only 2. As the number of shells remain constant, shielding will also be constant. So there is an increase in the effective nuclear charge, because as you move from left to right, we find that there is increase in the number of protons, but the shells remain constant. Therefore, there is an increase in the effective nuclear charge and shielding is constant. And that is why the size of fluorine atom is smaller as compared to that of lithium atom, which I have already explained in detail. So in case of fluorine atom, nucleus contains 9 protons. The magnitude of charge is nearly 3 times as compared to the lithium atom. So the electrostatic force of attraction of the 9 positively charged protons towards the electrons in the outermost shell increases, and as a result, it pulls the outermost electron closer to the nucleus, and the end result is decrease in size of the fluorine atom. Now, going down a group from lithium atom, let's see what's the periodic trend with respect to the atomic size. The atomic size increases as we go down a group. So we are talking about the group 1 elements. So as we go down the group, we see the size of the atoms increase. Why is that? Let's find out. So hydrogen has only one electron shell, which is the valence shell containing only one electron. Lithium has 2 shells. Sodium has 3 shells, while potassium has 4 shells. So as you go down the group 1, you find the number of shells increase. And what about the number of protons? 1 in case of hydrogen, 3 in case of lithium, 11 in case of sodium, and 19 in case of potassium. So you find that there is increase in the number of shells. As the number of shells increase, it contributes to increased shielding. So increase in number of shells, that leads to increase in number of core electrons. Increase in the number of core electrons leads to interelectronic repulsion, and that leads to increase in size, and shielding is also increased. And as a result, there is increase in the size of the elements as you go down the group. So as the number of shells increase, the distance between the nucleus and the outermost shell increases, and the atomic radii increases. Now, before I take up some practice questions, I would like to give my viewers with some useful tips for solving practice questions relating to the periodic trends in the atomic size. So first thing first, be familiar with the periodic trend. So moving across the period from left to right, the atomic size decreases, and going down a group, the atomic size increases. Now, with the help of this particular question, I'll be giving some useful tips in the form of steps. Just follow the steps and it'll be easier for you to solve the questions. So step 1. So here the question is, arrange sulfur, phosphorus and magnesium in increasing order. So how do you approach this particular question? Step 1, you have to first identify the position of the element in the periodic table. So in the periodic table, first you have to identify the given elements belong to which period or which particular group. So these three elements are, so when you observe the periodic table, so these are the period 3 elements. You can observe the row 3, they are period 3 elements. So I can write down all the elements and then follow the trend. So the trend is the size of the atom decreases as you move from left to right of the periodic table. Now after identifying the position of the element in the periodic table, next step will be to identify the elements in question. So what are the elements in question in period 3? So you identified the elements, given elements belong to period 3. Now you have to, you have identified the position. You have identified the position. So given elements belong to period 3. Now you have to identify the elements in question. So what are the elements in question? Sulfur, phosphorus and magnesium. So underline these elements. And after this, next step will be arrange the elements in the particular order. So here what is the order they have asked? You have to arrange sulfur, phosphorus and magnesium in increasing order. So you should be very careful about using the mathematical signs, increasing and decreasing order. So it's always important to read the question, understand and then answering a question. So now we have identified the position of the element and we have identified the elements in question. Now arrange the elements in a particular order following the periodic trends. So when you follow the trend, the size decreases from left to right and this will be the order. Sulfur less than phosphorus less than magnesium. Now this is about the elements which are not ionic. Now what about if the question is involving ions, particularly the ions in isoelectronic series? So you got to remember these 3 points when a question is asked pertaining to ions in isoelectronic series. So rule number 1, the magnitude of negative charge is directly proportional to the size of the ion. So as the number of negative charges increase, the size also increases. For example, phosphide ion is bigger in size as compared to sulfide ion, as phosphide ion has 3 negative charge as compared to sulfide with 2 negative charges. And similarly in case of oxide and fluoride ions, oxide with 2 negative charge as compared to fluoride with 1 negative charge. So therefore oxide ion is bigger in size. So remember, these are all ions in isoelectronic series. So these rules apply only for ions in isoelectronic series. The second rule will be the magnitude of positive charge will be inversely proportional to the size of the ion. So if the number of positive charges, if the magnitude of the charge is more, the size decreases. If the magnitude of the charge is less, the size increases. Example, magnesium with 2 positive charge is bigger in size as compared to aluminum ion with 3 plus charge. So potassium is bigger than calcium because potassium has +1 charge as compared to calcium with 2 plus charge. And third and the most important rule, always in the isoelectronic series, the anion will be bigger in size as compared to the cation. For example, chloride ion and potassium ion both are isoelectronic in nature with 18 electrons each. But chloride ion will be bigger in size as compared to potassium. So always remember, question involving ions in isoelectronic series, the size of anion will be always bigger than the cation. Now time for practice questions relating to the periodic trends in the atomic size. First one, which element has the maximum atomic size or radii? So periodic table, what is the periodic trend? The atomic size decreases across a period while the atomic size increases down a group. So follow this periodic trend and approach the question. What is the first step? Identify the position of the element in the periodic table. So all these elements are period 3 elements. They are present in row 3 of the periodic table. Second step, identify the elements in question. So I have underlined all these elements in question in period 3 elements. And next will be go by the periodic trend. The size increases, decreases from left to right. And you can see that magnesium is towards the extreme left, and therefore magnesium will be the one with maximum atomic size or radii. Second question, which atom is smaller, calcium or bromine? So both the atoms are period 4. Both are period 4 elements. So position is identified. Identify the elements, calcium and bromine, only 2 are there. Follow the periodic trend, arrange them according to the periodic trend. Calcium comes first, followed by bromine. So calcium is towards the extreme left, while bromine is towards the extreme right of the periodic table. And therefore, without doubt, bromine will be smaller in size. Next question, which atom is larger, silicon or germanium? So here the question is pertaining to elements belonging to a group. So it is both are group 14 elements, and so position is identified. They both belong to group 14. Next, elements are silicon and germanium. The elements are identified. Next, go by the periodic trend. So when you go by the periodic trend down the group, we know that the atomic size increases. So obviously, germanium will be larger in size. Next question, identify the element with a larger size. Now it's a question relating to ions. So remember the important rules that I have explained about the ions in isoelectronic series. So generally, questions in the examination will be covering ions belonging to isoelectronic series. So first thing, try and find out whether how many ions belong to the isoelectronic series. In this, so always the anions will be bigger in size as compared to cations in an isoelectronic series. Of these 4 ions, calcium, potassium and chloride, these 3 belong to the isoelectronic series with total of 18 electrons. And since they belong to the isoelectronic series, which will be bigger? Anion will be always bigger in size. That is a chloride ion. But one ion is left over. What is that? Sodium ion. So sodium ion, it belongs, now both sodium and chlorine belong to which period? Both belong to period 3. So sodium and chlorine both are period 3 elements. But sodium ion, after losing its outermost valence electron, it has only 2 shells completely occupied with electrons, while chloride ion, it has 3 shells completely occupied with electrons. Therefore, based on the number of shells and the periodic trend, chloride ion will be larger in size. Next question, identify the correct order of increasing atomic radii. So here's mixture of both, 2 different periods. So you've got elements belonging to both period 3 and period 5. So what are the period 3 Now just group them according to the periods. So first let us take up period 3 elements, magnesium, phosphorus and sulfur, and go by the periodic trend. The size decreases across a period. So this will be the order: sulfur less than phosphorus less than magnesium. And what is left over? Strontium is left over. But strontium belongs to which period? Belongs to period 5. So period 5 elements will have total of 5 shells. So sulfur, phosphorus and magnesium, these three are period 3 elements with 3 shells, while strontium is a period 5 element with 5 shells. And therefore, obviously, sulfur with 5 shells will be bigger in size. The answer will be sulfur less than phosphorus less than magnesium less than strontium. Sulfur will be the smallest and strontium will be the biggest, or the element with bigger size or atomic radii. Moving on to the next question. Arrange these ions in the order of increasing size: bromide ion, calcium ion, rubidium ion and strontium ion. Going by the periodic trends, atomic size decreases across a period and atomic size increases going down a group. So as you move from left to right across a period in the periodic table, atomic size decreases, and going down a group, atomic size increases. Follow these 4 steps and one will never go wrong in arranging the given ions in the order of decreasing or increasing size. Step 1. Identify the position of the given elements in the periodic table. So the given elements are calcium, bromine, rubidium and strontium. So these 4 elements are highlighted in the periodic table. So calcium and bromine are period 4 elements, while rubidium and strontium are period 5 elements. Next, step 2. Identify the elements in questions. So elements in question are calcium ion, bromide ion, that are period 4 elements, while rubidium and strontium are period 5 elements. Next, step 3. Arrange the elements following the periodic trends and check their proximity. So in the period 4 elements, calcium is towards the left side of the periodic table, while bromine is towards the right side of the periodic table. So calcium comes first, followed by bromine. So calcium will be bigger in size and bromine will be smaller in size. So what about rubidium and strontium? So rubidium comes first, followed by strontium. So rubidium will be bigger in size as compared to strontium. Next, step 4. For the isoelectronic series, arrange the elements as per atomic number and see their proximity in the periodic table. Now this is the most important step. Now among these 4 elements, you have to consider their atomic numbers and see their proximity in the periodic table. So bromine, atomic number 35, rubidium, atomic number 37, and strontium, atomic number 38. So among the given 4 elements, bromine, rubidium, and strontium are they are in close proximity in the periodic table. And this is a clear hint that these 3 elements may belong to the isoelectronic series. And they do belong to the isoelectronic series. So strontium, rubidium, and bromide ion are isoelectronic in nature with 36 electrons each, with atomic numbers 38, 37, and 35. So what is the element that is left over? So it is calcium that is left over with atomic number 20. So when you compare the atomic numbers, the atomic number of calcium is less than the rest of the 3 elements. So obviously it will be the smaller sized atom. So here it is given in the ionic form, that is calcium ion. So in the given isoelectronic series, what will be the order? Order will be strontium less than rubidium less than bromide ion. Because if you go by the rule, in the given isoelectronic series of ions, always the anion will be bigger in size as compared to cations. So bromide ion will be bigger in size as compared to strontium and rubidium ion. So among the positively charged ions, that is strontium and rubidium, so check for the ion where the magnitude of positive charge is more. So strontium, you find the magnitude of positive charges more, and therefore strontium will be smaller as compared to rubidium. So the order will be strontium less than rubidium less than bromide ion. And in the periodic table, calcium with atomic number 20 and going down the group, calcium is less than strontium in terms of size. So if you go by the periodic trend, going down the group, the atomic size increases. Therefore, strontium will be bigger in size as compared to calcium. So it is not given in the elemental form, it is given in the ionic form, calcium. So calcium has total number of 4 shells with 2 valence electrons. It loses 2 electrons. You get the calcium ion with 3 shells fully occupied with core electrons. And what about strontium? Strontium has a total of 5 shells with 2 valence electrons in the outermost shell. It loses 2 electrons, and the strontium ion has a total of 4 shells fully occupied with core electrons. So this is just to cross check. So even when you consider in terms of number of shells, strontium is bigger in size as compared to calcium. So strontium has 5 shells, that is strontium ion has 4 shells as compared to calcium ion with only 3 shells. So calcium will be lesser in size than strontium ion, even in terms of number of shells. So the answer will be calcium ion less than strontium, less than rubidium, less than bromide ion. So these were some of the useful tips for solving questions relating to periodic trends in atomic size. Don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.